Terence Tao is, by most accounts, the greatest living mathematician. And for months, he's been telling us something. Not with fear, but with careful wonder. We've crossed a line, he says. Machines can now do a part of mathematics that used to belong only to humans. And he wants us to be honest about exactly which part. Here's what set him off. In the spring of 2026, a team at Google DeepMind pointed an AI at a list, a famous list. The open problems of Paul Erdős, puzzles left behind by one of the most prolific mathematicians who ever lived, some of them unsolved for half a century. Not applications, not homework, genuine holes in human knowledge. And the machine started filling them, 9 of them, plus 44 more open conjectures from a separate database of integer sequences, and a question about something called Hilbert functions that had been sitting open for 15 years. Now, here's the part that makes mathematicians lean forward. It didn't just claim the answers. Every single proof was written in a formal language called lean and checked, line by line, by a computer. No hand-waving, no trust me. If there were a gap, the machine would have caught it. The cost to find each one of these proofs? A few $100s. For years, an AI solving a real open problem was a once-in-a-while headline, if it was even real. This wasn't once in a while. This was a whole batch, cheap and machine-checked, in a single research paper. The trickle became a flood. The dam broke. But Tao would want me to stop right here and add the caveat, because the honest version of this story is more interesting than the hype. So let's do it properly. Start with what the machine actually is, because it's not a chatbot spitting out an answer. The system from DeepMind pairs a frontier model, Gemini, with that formal proof checker, Lean. And the loop is the whole trick. The AI proposes a step. Lean tries to verify it. If it doesn't compile, Lean sends back an error, and the AI tries again, and again, thousands of times, tightening the argument until the proof is airtight, and the compiler finally says, valid. That's why there's no trust gap here. In normal math, a new proof sits in limbo while human referees squint at it for months. Here, the referee is a machine that cannot be charmed, cannot be tired, and cannot wave anything through. It either compiles or it doesn't. And now the honest twist, one the DeepMind team put right in their own paper. They built a fancy version of this system, with specialized agents and clever search. But they also ran a stripped-down, basic version. A plain model, plus the compiler, plus the patience to keep trying. The basic one solved all 9. The elaborate machinery barely helped. Which tells you something a little humbling about this moment. The breakthrough isn't some secret architecture. It's that today's models, hammered against a verifier that never lies, are simply good enough now. The scaffolding fell away, and the thing still stood. So that's the how. The harder question is the one Tao keeps pressing. Who decides this actually means something? Meet Thomas Bloom. He's a research mathematician, and he runs a website, Erdosproblems.com, that has quietly become the official scoreboard. It's where the world tracks which of Erdős's problems are open and which are solved. And Bloom is careful about that word open. On his side, open doesn't mean provably impossible. It means, as far as I know, nobody has published a proof. That distinction is going to matter in a minute, because when a genuine AI proof does come through, Bloom is one of the people who checks it. And earlier in 2026, when an AI produced a real one, his verdict was blunt and generous at the same time. In his words, we can unambiguously say the AI solved a $500 Erdős problem. But then he asked the question a mathematician always asks: did this teach us anything new about the problem? And his answer is the most honest sentence in this whole story. Quote, a moderated yes. It didn't hand us powerful new tools. It didn't open a door to deeper theory. It answered the question correctly, verifiably, and not much more. And Tao draws the same line, but sharper. He splits mathematics into 3 acts: generating a proof, verifying a proof, and digesting a proof, turning it into understanding that connects to everything else we know. His point, The first two acts have suddenly gotten fast. The third one, the understanding, is still slow, still human, still hard. The machine can now produce the answer and prove it's correct. It still can't tell you why it matters. And knowing that, really sitting with it, is what saves you from the trap that math walked straight into just months earlier. Because this isn't the first time you heard an AI solved unsolved math. And the first time was a mess. Back in October 2025, a senior executive at OpenAI posted with real excitement that their model, GPT-5, had found solutions to 10 previously unsolved Erdos problems and made progress on 11 more. 10! The post went everywhere. Except it wasn't true. Remember Bloom's careful definition of open? Nobody has published a proof he's aware of? Well, it turned out these problems had been solved, years ago, in papers he simply hadn't logged yet. The AI hadn't proved anything new. It had done a very good literature search. It found the existing answers. Bloom called it, on the record, a dramatic misrepresentation. Another OpenAI researcher walked it back. Only solutions already in the literature were found. And the head of Google DeepMind, Demis Hassabis, watching a rival overclaim, said just 3 words. This is embarrassing. That's the trap, and it's exactly why the 2026 results are different, and why the people certifying them are the same skeptics who called out the hype. When an internal model at OpenAI genuinely disproved one of Erdős's old conjectures that spring, it wasn't OpenAI who declared victory. It was 9 independent mathematicians, including Bloom himself, who took the machine's proof apart, verified it, and, notably, improved it. The human role, Bloom said, is still vital. Which brings us to the honest asterisk on that big batch of 9. Not everyone is sold. One critic went through them and argued that several were, in effect, already known. The labels on Bloom's scoreboard were simply out of date. Fair, but here's the difference this time. The proofs are in lean. A computer verified the logic. And even after that criticism, the results held up. Contested? Yes. Fabricated? No. So step back and look at the shape of it, because the trajectory is the real story. And it's faster than you think. For most of its history, an AI in mathematics was a tool, a co-author, helping a human like Tao push a proof along. Then, this past January, it crossed the line. For the first time, an AI produced a genuinely new proof of an open problem, more or less on its own, and a computer verified it in lean. Tao called one of those January solves perhaps the most unambiguous case yet of a machine cracking something genuinely open. That was one problem. By May, just months later, it wasn't one. A famous old conjecture fell to one lab's machine, and a jury of 9 independent mathematicians confirmed it. Days later, a different lab system cleared 9 unsolved Erdos problems at once, and another of its machines picked off 4 more. The solo act became an assembly line in a single spring, and it's spilling out of the research journals and onto the world's biggest math stage. This July, the sharpest young mathematicians on Earth sat the International Mathematical Olympiad in Shanghai. Last year, a system from DeepMind quietly took that same exam and earned a certified gold medal, solving 5 of the 6 problems. And going into this year, the smart money was betting the machines would do it again. But before you picture a machine marching toward the summit of mathematics, hear Tao's caveat, because it's the thing almost every headline drops. These are, in his words, the lowest hanging fruit. Problems amenable to fairly standard techniques. His estimate of the AI's real success rate across that famous list? A percentage point or 2. What's actually happening is that the machines are clearing the shallow end, and by clearing it, they're revealing exactly which problems are still genuinely, humanly hard. So, is this the moment the machines take over mathematics? No. And the reason why is the most hopeful thing in the story. Go back to Tao's 3 acts: generate, verify, digest. 2 of them just got fast. A machine can now propose a proof, and a computer can confirm it's correct in the time it takes to spend a few $100s. That is genuinely new, and it is genuinely astonishing. But the 3rd act, digestion, understanding, placing an argument in the great web of everything else we know, deciding what's worth proving in the first place. That stayed exactly where it was, with people. Tao says it plainly. That part still requires expert human attention. Bloom says the human still plays a vital role. The AI can hand you a valid proof of a true statement and still not know or care whether it matters at all. Bloom put it best. He said AI is helping us more fully explore the cathedral of mathematics that humans have built over the centuries. And then he asked, what other unseen wonders are waiting in the wings? That's the register to leave you in. Not a machine replacing the mathematician. A new kind of tool, handed to a species that has been chasing these problems for 100 years, clearing the brush at the edges so the real climbers can see the mountain. The proofs are getting faster. The understanding is still ours. And what we choose to understand next, that was always the human part.